Okay, this is section 7.4, solving word problems using linear systems. So when we finish, I want you to be able to select the best method to solve the word problem with, whether it's substitution or elimination, and then I want you to solve the word problem. So a couple of things that you need to remember is that you should probably use substitution if a variable is already isolated in the equation. It's just already set up for you. And you should probably use elimination if all of the variables have a coefficient other than 1. Now let's take a look at our first problem. The sum of two numbers is 36. Their difference is 24. Find the numbers. The first thing I have to do is I've got to talk about my variables. I am going to let x equal a number and let y equal a number. Okay, now I need to go through and I need to write my equation. The sum of two numbers is 36. So I know that x plus y is equal to 36. Their difference is 24. So if I have x minus y, that's equal to 24. Now when I look at this, it's already set up for me to use elimination. Positive x's, positive y, negative y. That's automatically going to eliminate the y's for me. So those eliminate. So now I have 2x is equal to 60. Divide both sides by 2. So I know that x is equal to 30. Well, now if I knew that x is equal to 30, I can find y. Because x plus y is equal to 36. So 30 plus y is equal to 36. Subtract 30 from both sides. So y is equal to 6. So I have 30 and 6 are my solutions. Now this next problem is a little more complicated. The sum of two numbers is 50. If twice the larger is subtracted from 4 times the smaller, the result is 8. Find the numbers. Now when I talk about my variables, I've got to be a little bit more specific. So let's say that L is the larger number and S is the smaller number. So now when I go through, the large number plus the small number is equal to 50. And if twice the larger number, that means 2 times L, is subtracted from 4 times the smaller, let's see, 4 times the smaller number minus 2 times the larger number is equal to 8. So this one, when I write this over here with my other equation, I don't have a variable that's isolated, and they're not lined up. So I've just got to decide which method I want to use. I'm looking at this and I want to use elimination, so I'm just going to rewrite these. So I have L plus S is equal to 50. That one was lined up fine. Now this one I'm just going to change the order, so I have negative 2L plus 4S is equal to 8. And I'm going to multiply my top equation by a positive 2. So 2 times L gives me 2L. 2 times S gives me a positive 2S. Bring in my equal sign, and 2 times 50 gives me 100. Now I'm going to bring my other equation over. So I have negative 2L plus 4S is equal to 8. Now I'm just going to go through and combine. Positive 2L minus 2L gives me 0. 2S plus 4S gives me 6S is equal to 108. Divide both sides by 6. So S is equal to 18. Now that I know what S is, let's go back and find L. Because I know that L plus S is equal to 50. L plus 18 is equal to 50. Subtract 18 from both sides. So L is equal to 32. So my solution is 32, 18. Okay, let's look at the next one. A baseball manager bought 7 shirts and 4 pairs of pants for $490. Another manager who paid the same prices paid $290 for 5 shirts and 2 pairs of pants. Find the cost of the shirts and a pair of pants. First thing I have to take care of are my variables. I'm going to let S equal the shirt cost, and I'm going to let P equal the pant cost. Notice I'm choosing variables that mean something in my problem. That's going to keep me from having to go back and look and see what represents what. So for the first equation, 7 shirts plus 4 pants is equal to $490. Now the second one, we have 5 shirts and 2 pair of pants, cost $290. Okay, now when I look at this one, every variable that I have has a coefficient other than 1. So once again, I'm going to use the elimination method. So I have 5 and 7, my coefficients of S, 4 and 2 are my coefficients of P. I want to eliminate the P's because it's going to be easier for me to have a positive 4 here and a negative 4 here. So I'm going to multiply every term on the second equation by negative 2. So the first equation I'm just going to slide over. So I have 7S plus 4P is equal to 490. Now the second equation, negative 2 times 5S, that gives me a negative 10S. Negative 2 times 2P gives me a minus 4P. And negative 2 times 290 gives me negative 580. Now I'm going to go through and I'm going to combine all my terms. 7S minus 10S gives me a negative 3S. Positive 4P minus 4P adds up to 0. And 490 minus 580 gives me a negative 90. I'm going to go through, divide both sides by negative 3. So S is equal to positive 30. So each shirt costs $30. Now let's see how much a pair of pants cost. See, I'm going to use the second equation because those numbers are just a little bit smaller. But remember, it's just all personal choice. So I have 5S plus 2P is equal to 290. So I have 5 times 30 plus 2 times P is equal to 290. Now 5 times 30, that's going to give me what? 150 plus 2P is equal to 290. Subtract 150 from both sides. So I have 2P is equal to 140. Divide both sides by 2. And 140 divided by 2 is going to give me 70. So a pair of pants costs $70. So a shirt costs $30 and a pair of pants costs $70. Okay, now let's look at another problem. A purse contains $7.60 in quarters and dimes. In all, there are 40 coins. How many coins of each kind are there? Well, first I've got to choose my variables again. So I'm going to say I have Q quarters, D dimes. Now I have to write my equation. I'm going to start with the one that's a little easier. In all, there are 40 coins. So that means if I add up my quarters plus my dimes, I'm going to get 40. Now it tells me, I'm going to go back and look at the first part. A purse contains $7.60 in quarters and dimes. So that means that the value of my quarters, so it's going to be the value of a quarter times how many quarters I have, plus the value of a dime, 0.10, times how many dimes I have, is equal to $7.60. So I've got to choose which method I want to use. Okay, and I personally would probably like to use elimination, but I'm going to use substitution because we haven't done that one yet. So I'm going to choose to isolate the D. So I'm going to say that D is equal to 40 minus Q. Now the reason I'm choosing D is when I plug this into the second equation, I'm multiplying it by 0.1. So that's going to make the work a little easier for me. So now I have 0.25 Q plus 0.10 times 40 minus Q is equal to $7.60. 0.25 Q, just bring that down, plus, let's see, 0.10 times 4. What is that for? Minus 0.10 Q. When I distribute again, and all of that's equal to $7.60. I'm going to go through and I'm going to combine my like terms. 0.25 Q minus 0.10 Q. So that's going to give me positive 0.15 Q plus 4 is equal to $7.60. Going to subtract 4 from both sides. So I have 0.15 Q is equal to 360. Now we're going to divide both sides by 0.15. So Q is equal to 3.60 divided by 0.15, 24. Okay, so that means I have 24 quarters. And if I have 24 quarters, how many dimes do I have? So Q plus D is equal to 40. I have 24 quarters, so 24 plus D is equal to 40. To subtract 24. So D is equal to 16. So I have 16 dimes and 24 quarters. And that's it.